Alright, so we've talked about finding areas of regular polygons, and now we want to take a look at some more complicated examples where we're looking for the area of a shaded region. And just the overall view here, in this case the shaded region is equal to the circle minus the hexagon. So we have to find the area of two different objects here and then put them all together or subtract the two of them from each other. So in this case this is a hexagon and the side length here is 16, and from the prior examples we know that for a hexagon only the side length is exactly equal to the radii. So that means the radii here is also 16. So from there we can use the fact that the area of a circle is equal to pi r squared, in this case 16 squared, so that's 256 pi. Now we have to figure out what's the area of the hexagon. Okay. Well, I'm just going to draw one of these triangles, not the whole thing. Looking at the one triangle, this is 16, this is 16, this is 16 as well, and we know that this here is a regular or an equilateral triangle. So if we were to cut this object down the middle here, and we can look at that, this object here. Okay. So we know that if we cut this exactly down the middle, then we're going to cut this length in half. So this length is going to be 8. This length we know is 16, and this is going to be 30 degrees. This angle here is 60 degrees. So using the 30, 60, 90 theorem, we know that this length is 8 root 3. So the area of the hexagon then is equal to 6 times, well, first, why 6? Well, there's 6 of these triangles that we can create. The area of each one of these big triangles. Okay. But each one of these big triangles is really 1/2 the base, which is 16, times the height, which is 8 root 3. So putting all these calculations together, we get 6 times 8 times 8 times the square root of 3. So that's 384 times the square root of 3. So now we can do the substitution. The shaded, remember, is equal to the area of the circle, which is 256 pi, subtract the area of the hexagon, which is 384 times the square root of 3. And you can leave it this way, or we can type it into a calculator, and we'll get a decimal answer. So 256 pi minus 384 times the square root of 3. Okay, so that's approximately 139.14. And that is our final answer. Okay. So in this example, it's not too difficult. It looks difficult at first, but the nice thing about this is that we can easily find the side length. Okay. Now let's move on and let's look at one last example where, oops, this is a typo. This should say 72 degrees. Okay. And so now we want to figure out what is the area of the shaded region right here, knowing that this length is 16. Okay. So now if we want to find the area of the shaded, well, that's equal to the area of the sector. So if we look at the area of the entire sector here and subtract the area of the triangle. And we can work backwards to figure out what is this length. Okay. So I'm going to start out just looking at the triangle by itself. And we know that this is 90 degrees. We know that this length alone here is 16. And this arc here is 72. That means the central angle, the big central angle in here, that's also 72 degrees. And so this angle is 1/2 of that, and that must be 36 degrees. And with that, we can look for R. Remember, this is R right here. This length in the triangle that I'm drawing to the side is the same thing as the radius. Okay, so we have to use our knowledge of trigonometric ratios. And in this case, I have 36 degrees. This is the opposite side, and that's the R here is also the hypotenuse. So we can do sine of 36 degrees is equal to the opposite side, which is 16, divided by the hypotenuse, which is R, and then we can solve for R. So first we're going to multiply both sides by R, so R sine 36 is equal to 16. Then we can divide both sides by sine of 36, and that'll give us R. So this is approximately, and there's only an approximate answer here, 16 divided by the sine of 36, and that's about 27.221. Okay. So knowing that we have R now, we can figure out what's the area of the sector, and then what's the area of the triangle. And I think it might be easier to find the area of the triangle. Well, the triangle has a base of 32, because if this is 16, then this is also 16. And now to find the height, you could either use the Pythagorean theorem, because you know 16 and you know R, or you could also use another ratio. So we can also use the cosine ratio here. This is the height. Okay. So the height of the triangle, and I'm looking at just this one right triangle, this height is equal to, so let's see, the cosine of 36 degrees is equal to, actually I'm sorry, I don't want to use cosine, I want to use tangent. Okay, so the tangent of 36 degrees here is equal to the opposite, which is 16, divided by h. So that means h is equal to 16 over tangent of 36, and that's approximately 22.022. Okay, so this length here is R, and this length here is h. Okay. Now we finally have enough to figure everything out. So the sector is equal to 72 over 360 times the area of the circle, which is pi r squared, or 27.221 squared. Okay, I'm going to draw a little separator here, and that's about 47.172. Then the triangle is 1/2 the base, which is 32, times the height, which is 22.022, so that's about 352.352. I'm sorry, I realize I just made a mistake on this. That's not 47. I don't know what I did there. This should be 465.573. Okay, so looking at that again, let's see. 27.221 squared times pi times 72 over 360. That should give me 465.573. The reason I knew that was wrong was because we were about to end up with a negative area. Okay. So now once all this is done, all that remains is for us to subtract 2. So 465 0.573 minus 352.352 is equal to 113.22. Okay? And this here is our final answer. So that was a pretty complex problem for sure. But you can see we can work through it slowly in using the same methods and the same approach that we did before. This ends this lesson. We'll work on some more problems like this in class, so that you have a chance to practice. Thank you for watching. Have a wonderful day.